Hello and welcome to this video entitled P7 2.1 Why Use Telescopes. This is the first video from what I consider to be, well, what is really, the second section of P7, Studying the Universe, and this whole section is about telescopes and images. So why do we use telescopes, which we're going to look at today, and how are they used to form images? I'd like to introduce you to my friend here who's going to be helping with some of these videos from henceforth. What's going to happen is sometimes this inquisitive soul will ask a question. Yes, a question. And when a question appears on the video like this, you can stop the tape.
Stop the tape!
Or pause the video and have a go at answering the question for yourself. If you want to, you can use it as a revision tool. Try and do it like a six-mark answer style question, or jot down some notes or whatever it is. Then I'll go through the content. You can look at it. So this is a way for us to be a little bit more interactive with each other as we continue with these videos. So let's get started with my questiony friend here. So here's a question. What's all the fuss about? Why do we need to bother with telescopes? So take a minute, pause the video when I finish my little spiel here. Pause the video and try to answer this question. Jot down a few things, see if you can put down a few points. Why do we bother with telescopes?
Stop the tape!
Alright, so you may well have unpaused your video now, or perhaps you never bothered pausing it at all, I don't know. But we're going to try and have a look at a few reasons for using telescopes. Firstly, here are some images of the moon. Now I say images, these were hand drawn by Galileo in 1609. So we're talking, 400 years ago. These were the best images that humans had ever had of the moon, the most detailed close-up images of the moon. Look, we can spot these different phases. He's got it in crescent and sort of half moon things here, and maybe a waxing or a waning gibbous here. But the point is that Galileo was able to, through the use of a telescope, he was able to achieve magnification. He was able to magnify the image that he was trying to look at, and he was able to make those small details appear larger and closer. So you use a telescope, A-P-P-E-A-R, that's how you spell appear, isn't it? Appear larger and closer. So that's a reason to study things using a telescope. You make things appear larger and closer. The other advantage is, and this one may come from, or seem obvious a little bit more by looking at an example of studying a star. So this is a star system. In fact, it's complex what's going on here. We won't go into a huge amount of detail, but looking at this with your naked eye, you'd never see this detail, obviously. We'd never see this magnification, but also we would never be able to absorb or collect as much light. So telescopes allow you to collect more light. So not only can you see more detail and see further, we can then see what we might call dim objects. So if things are not very bright, a tiny little pinprick in the sky that normally we couldn't see if it was moon, if the moon was really bright, or if it was not dark enough, if we weren't out in the countryside, we can then see these really dim objects with a telescope because they collect more light. So we see more detail, we collect more light. Can summarize this by saying that they are high resolution. They have a high resolving power. So what to us may look like a little dot or a couple of little dots like this, if we magnify it up, we see that these are actually now separate dots with a structure. Now obviously this doesn't have much structure, I'm just sort of freestyling here. But look, we can resolve the small details here. We've got much higher resolving power using our telescope. Okay, so let's have a look at some telescopes. This is what you might spring to mind on a telescope. We've got a point here where we collect all the light and we can look through an eyepiece to see what's going on. But telescopes take all sorts of shapes and sizes. Here we've got a selection of different telescopes. This one is a radio telescope. Now this is another point of why we bother to use telescopes. A radio telescope. What do I mean by radio? Well, radio, as you remember, this is part of the electromagnetic spectrum. So this telescope here is seeing light, or seeing wavelengths, that the eye can't see. So how should I say? Seeing wavelengths that the eye cannot. Because stars, and we'll study this in the future, stars and different things in space, they don't just give out visible light, they also give out radio waves, X-rays, gamma rays, they give out all sorts of radiation. Microwave UV, this one here, is a UV, ultraviolet collecting one. So a few different types, a few different styles, and this one here is probably the most famous space telescope ever, the Hubble Space Telescope. And it's in space. We're going to have a look at what the advantages are of putting telescopes into space. But this is another point with telescopes here, is that we can see things from places. So here we can see radio waves which we can't see with the naked eye, but here you can look at stuff from places that are difficult to reach. So from inconvenient locations, because it would not be convenient for me to go up into space to look and to live up there in space looking out all the time. But with a Hubble Space Telescope, I can look out in space from inconvenient locations over long periods of time. So we can see further, we can see cool stuff, and we can see types of light that we wouldn't normally be able to see. This is a close-up on a NASA space telescope, and I'm not actually 100% sure if this is the Hubble Space Telescope, but this is a sort of simple design. And you can see it's got solar panels on here, so it's power. Once it's up there, it takes a lot of money, a lot of time and effort to get it up there, but once it is up there, it can then study stars from space, which has huge advantages, which we'll discuss later. Now check this out. Can you guess what this is? This is the sun. This is the star at the center of our solar system that our tiny little planet rotates on a yearly basis, 365 days. And this is taken using a telescope, and this image is put together basically the same way that our eyes would see this, so using the visible light, the visible parts of the spectrum. But what happens if you look at the sun through a filter? This is a UV image of the sun, and we can study what's going on. Now there's some interesting points here where there's certainly some strange activity going on, and we can see, like we saw with the eclipses, you see these lines and areas coming out here, the solar corona. And that looks a bit strange. It looks like I've made the sun like a weird animal there, like a spidery sort of thing. But my point is, look, we can see, that's odd, but we can see parts of the sun, and we can see behavior in the sun that we wouldn't have been able to see using other parts of the spectrum. This is a composite image, which means a couple of different images put together, and this uses a load of different parts of the spectrum. So we're looking at radio, microwaves, I think also UV, and loads of different parts of the spectrum. But it's not just visible light. And look at the detail here we're getting about the solar corona. Look at this. What is going on there? I mean, to think about this, the Earth would be this big, right? This is the size of the Earth that I'm drawing in here. So to scale, that's the Earth. And look at this structure. Look at what's going on the surface of the sun. It's chaotic, it's mysterious, it's non-uniform, and its behavior is pretty crazy. So we study this, and by using telescopes we're able to access information that we wouldn't otherwise be able to use. Now notice this image, you're able to see we've actually recorded something here. So telescopes are often used in conjunction with cameras, right? So we use telescopes to study things, and then we film it and we record it. So another real reason for using telescopes is because sorry, just grab a colour here, is because we can record what we see. So it's all very well, you know, you or I going out one night and looking at the stars and saying, oh, last night I saw something really interesting happen. A big flash flew across the sky. It was great. And, you know, other astronomers say, right, okay, well, can you describe it? Well, obviously, written testament isn't going to be enough. And I'm not dissing Galileo with his excellent high-quality images of the moon, which, well, these are groundbreaking and fantastic, but this is not the same as seeing a photograph. This is, you know, got some sort of artistic interpretation. There's some pointer there where human error is going to come into play, but use a camera, we can record what we see. Okay, quick question for you. How does a camera work? So if you want to pause the video and have a think about this, please do so. So stop it now if you want. Look back in a second, I'll give you a little clue.
Stop the tape.
Okay, clue. Can you describe what happens in a pinhole camera? I'll write that again, just in case. Pinhole camera. Have a little think. Okay. This is how a pinhole camera works. We've got an object, and light travels from this object, and if we can collect it through a small gap, which we call a pinhole, a hole the size of a pin, then light from the top of that image can travel through, but because this gap here is so small, it can only hit this part of the film. So we get light from different parts of an object and shine it or let it pass through this hole, and we can record it on the film. So if I was to draw in lots of rays, so obviously they've got a ray from the top going over here, got a ray from the bottom going over here, but a ray from here would, if only I had a computer ruler, would go here. A ray from this part here would go here. A ray from this part in the middle goes straight through the middle, and we end up with an inverted fish image on here. I'm not going to try and draw an inverted fish. Now if we have a film on the back screen here, then that can record where does the light fall, and we can see an image and we can record what's going on. So this same idea occurs for a telescope. So can we use a pinhole to make a telescope? What do you think?
Stop the tape.
Well, unfortunately, we can't use a pinhole camera to make a telescope. Why? Because it doesn't do the cool stuff we want. It doesn't magnify stuff, and it doesn't record enough light. So it doesn't let enough light in. We want to make something that magnifies stuff and lets in lots of light. If we had a pinhole camera, like so, if we tried making the hole bigger, what would end up happening is that, well, this diagram sort of shows that light from a large area here can come and confuse itself here. So at this point on the picture, you'd have the bottom of the fish plus B-O-T-T-O plus information from the middle, and that would be confused and blurred. So we end up with a blurry image here. And look, from the top we get info from the top of the fish here and from the top of the fish here. So this is all spread out. So it's spread out and it's blurred and it doesn't work. Now also look, we're getting something that we're not actually getting any magnification here. Maybe if we move this film way back, so we could actually put the film back here, so this light from here would travel to the top and this light from the bottom would travel here. So we can start to get some magnification here, because this image here is now bigger than what we've got coming through, but this tiny aperture, this very small hole here, is the limiting factor. Limiting factor. So we need telescopes because they can magnify and they can let in loads of light.
Now it's time for our wrap-up. Let's give it everything we've got. Ready? Begin.
Okay, so to wrap it up, why do we need to bother with telescopes? Hopefully, you guys should have an appreciation of this by now, but I'm just going to put a couple of points on here. We want to magnification, so that we can make small details large and make distant objects appear closer. We also want clarity, so we can make small details look much clearer. We also want to see dim objects, but dim, they're not very bright. So things that we can't see with our eyes because they're not sensitive enough, we try to collect more and more and more light so we see things that are very dim. We want to be able to see things from out of space, for example. So we want to access difficult areas. So we want to be able to, look at stuff from space. And we want to see all types of light. So I'm going to put see, because that could be record, see or record, all across the EM spectrum. So that, in a nutshell, is why we use telescopes. We're going to move on from this video to look at how telescopes work, and well, that's what we're going to look at, how telescopes work. And from there, we're then going to see what have telescopes seen.